In this first concept check question, you're asked to draw the products of the reaction shown. First, I'll recognize that the chlorine is the electrophile, and that will form a chloronium ion intermediate. Either face of the alkene can attack the chlorine, so there are two stereoisomers of this intermediate that can form. Now the chloronium ion intermediate will be opened with a nucleophile, and in this case the thiol is a good nucleophile, and it will open the ring by attacking the more substituted carbon. When it attacks, the stereochemistry at the carbon it attacks is inverted, and the stereochemistry at the untouched carbon remains unchanged. In the final step, a base deprotonates the hydrogen or the proton on the sulfur to yield the final thioether products. Because attack of the thiol can occur from the top or bottom face of the chloronium ion, the reaction results in two stereoisomers of the thioether product, and these two stereoisomers are enantiomers. In this question, you're asked to identify the conditions that would lead to two different regioisomeric alcohols from the same alkene starting material. So here the key is to recognize that the more substituted alcohol is the Markovnikov product, and that it will result from a carbocation intermediate. Then we should also recognize that the primary alcohol is the anti-Markovnikov product, and it will result only from a concerted hydroboration oxidation reaction. Then we just need to remember that the carbocation intermediate forms under conditions of acid and water, and the concerted hydroboration oxidation reaction uses two steps. First, the addition of borane, followed by the addition of hydrogen peroxide and hydroxide base. In this last concept check question, you're asked to draw the products of the reaction shown. Again, remember that this hydroboration oxidation is a concerted addition of the borane to the alkene. The hydrogens of the borane will add to the more substituted carbon of the alkene, and the boron, or the BH2 group, will add to the less substituted carbon of the alkene. From the borane intermediate that results, the peroxide and base will replace the boron with the OH group to form the final alcohol. Then remember that the original addition of borane can occur to either face of the alkene. So we need to be sure to draw the other enantiomer of the intermediate, which will lead to a new stereoisomer of the product. When we draw these two products, let's take a look at the two carbons of the alkene. The first in green here is not chiral. It has two of the same group on it, so we don't need or want to define stereochemistry here. But the second carbon in yellow is chiral. And here we formed both the forward and the back alcohol products, or both enantiomers of the alcohol. So we want to be sure to indicate that clearly when we draw the final reaction products.